I almost forgot to record. Okay, so today we're learning about percent yield. The reason that this is a thing that we need to concern ourselves with is because when we are doing experiments in the laboratory in real life, not always will we produce 100% of what we should make. In the same way that when we take a test, we don't always get all the answers correct. We don't always get all the points that are possible. In the lab, we are not always able to make as much of the compound as we should. So there are some reasons for that. So if we have less than 100% yield, what might be a factor? Well, we're high school students and sometimes we get a little bit clumsy. What if we drop some of our compound? Now, it might not seem super important to get like that very one last little drop of a liquid or that one little like granule of a solid in your test tube or your reaction flask. But just think about how many molecules are involved in one drop of liquid or in one little tiny speck, sprinkle-sized amount of a solid. And so that can like make a big difference. So sometimes it's a clumsy scientist. Usually we call this, like in scientific terms, human error. Sometimes our equipment isn't very good. Or it just isn't very sensitive. Do you remember how much my fancy balance costs?
$5.
Yeah, $5,000. And so in order to have nice things, we have to spend a lot of money on them. But what if we don't have the money for that in our laboratory? Well, then we might not be able to get a high enough percent yield because we just aren't measuring accurately. So we don't even have the correct starting values. And then there are just some chemical reactions that don't react all the way. And the way that we refer to that in chemistry is they don't go to completion. So, in other words, you could, as a student, in the same way that some reactions don't react all the way, like not all of the ingredients are used up, it would be like me giving you a homework assignment and you not answering all the questions. You didn't go to completion because you just didn't do all of the things that were possible for you to do. Some reactions are like that. The reactants are there, conditions are favorable for a reaction to take place, but it just doesn't. And so that sometimes also happens. So normally we have a situation where we're getting less than 100% yield because we're not making as much as we should. There are some situations though where we can make more than what we're supposed to, and that's not right either. That also includes error. So I'm going to talk about that now. So just because you get a more than 100% error doesn't mean that you're some super scientist who has cracked the law of conservation of mass code. It means that there is some error, in your work someplace. It doesn't mean that you have invented matter. So here are some of those reasons. The number one reason you could have a greater than 100% yield is if your substance is not fully dry. So if you're making a solid product, and now this is the case for you in the lab that's coming up on Tuesday. If you don't wait until that solid is only just a solid, if you don't dry all the water out, it'll seem like you made more than you actually did. Solid products aren't fully dry. It's like putting a bunch of clothes in the dryer and like overloading the machine and them not all being dry when the timer goes off. And then in the morning you go to get your school clothes and you discover all of my clothes are still a little bit wet. It's not a great feeling, right? In the same way that we don't want our solid products to have water left in them because we don't have just the product then. We have the product plus something extra. Again, we have the human error, and usually it means that we have not recorded something properly. Maybe we didn't clean the balance pan off before we used it, and so it looks like we've got more of something than we actually did. Maybe we didn't clean our glassware. You don't know what the glassware in your drawers, if it's been cleaned or not. You don't know. So if you are, Dominic, if you are starting your lab and you want to get a high percent yield that's accurate, you want to make sure that your glassware is clean, that you know it's clean, that you've cleaned it. And so using unclean glassware is a good reason that you would have impurities and greater than 100% yield. This is, again, the main one, and you have to be careful about this, especially in your lab on Tuesday. If you don't wait long enough for that heating part of the procedure, and if you've not written your procedure, you'll see what I mean when you do that later on. It'll seem like you've invented matter, or that you've like created something you haven't created because there's just extra water there. Okay, so calculating percent yield is super easy. Here's your formula. I would write this in my notes, but then I would also put it on my dark green sheet. That's why I asked you to pull that out. You don't really need that today. I just think it would probably be a good place for you to put it. Otherwise, another good place should be on the note card that you're going to use for your test. This is how you calculate percent yield. It's the actual yield. Percent divided by the theoretical yield. Write this down and then I'll explain it. And then it's a percent, so times 100. The actual yield is the recording that you obtain from doing the experiment. It can't be calculated any other way. So in order to get the actual yield, you actually have to do the experiment. If you don't actually do the experiment, you aren't going to get a percent yield. The theoretical yield can only be found using stoichiometry. I'm not going to ask you to calculate using stoichiometry any of the values for the percent yield calculations on your next homework. Just know that you're going to have to decipher in your problem, in your word problem, which is which. And so you're going to have to look for language that says, this is the theoretical yield. This is the theoretical value. This is the maximum amount that can be obtained. it's not possible for you to produce any more product than the theoretical yield. And if you do produce more than it, we know it's because of one of those errors that we had just talked about. So in a perfect world, the theoretical yield is what you would be able to manage. It's almost impossible to get 100% yield. I'm going to give out your new homework. Please don't worry about any of the first pages. I just want you to turn to page 4.
You said it's good to start Christmas. It's good to start Christmas.
I would never do your homework over Christmas.
Oh, okay. We got that on video too.
I will do my very best not to give you any homework.
Turn around.
That's
Turn
not-
around. Turn around. Turn around.
Gentlemen. All right, friends, let's look at page 4. I want to show you how to do some of these problems, and then we're going to call it a day.
Okay.
Okay, so let's look at number 10.
This looks just like our
It does, yep. Don't let it confuse you. All right, so when you're solving a problem like this, I recommend that you have what I call a data table. It's a list of your knowns and unknowns. And so all of these problems on the back side are percent yield. You're going to have 3 different things. The percent yield, the actual yield, which I'm never going to write out anymore. I'm just going to write actual. And then the theoretical, which I'm never going to write out anymore. I'm just going to write that because I'm a lazy person. So I think that it's probably pretty easy if you just make a list like this for all of these problems, and then we'll fill it in as we get to those numbers. All right, so you do have to do a little bit of reading.
Yes.
A product weighing 75.447 grams was isolated from a reaction. That is language that tells you that you're actually doing the experiment. So if that's what it's talking about, is it the actual or the theoretical yield?
Actually.
It's the actual. Hello. So I'm just going to put that on my actual line in my little data table. I'm going to keep reading. It says the amount of product possible according to a calculation was 79.44. Which line do I put that on? Theor, correct, because it tells me in the problem that's the maximum amount possible by a calculation. That's what theoretical yield is. Okay, so it says then, what is the percentage yield? Question mark. Now, it's important for you to write your equation down. Actual theoretical times 100. Make sure that you're solving for question mark before you put numbers in. This isn't as important in this lesson as it'll be coming up, but I'm going to make you do algebra before you put numbers in. And I will take points off if you don't, because it's sloppy and lazy. So this is what I would do to show my work. I would type or write in 79.44 grams times 100. I would do that math, and can anybody help me out? What do you get for an answer?
94.97. Yeah, 94.97.
Okay, what's your unit?
Grams.
Nope. Nope, both of those grams are going to go away. It's percent, and that's it. No grams, just a percent sign. Now, how many significant figures should I have in this problem?
Four.
4. Because you have to go by the smaller number. 5, 4, 4. This is a good answer. Now, not all the time are you going to be solving for percent yield. Sometimes you're asked to calculate what the actual yield would be. Sometimes you're asked to calculate theoretical yield. Now, because algebra can be a hurtful place for people to be, I'm going to give you those equations right now. So you have the first one, that's the original. Actual yield can be calculated in this way. You will do your percent yield times your theoretical yield and divide that by 100. And then if you need to solve for the theoretical yield, that will be,
Whoa. We should write this on a green sheet, right?
I would, yes. That'll be actual, or not. My board is so laggy. Hang on. Did I spell that right? Actual divided by percent times 100. So use these formulas because not always will you be solving for percent yield. Case in point, number 14.
Oh,
I'm going to do number 14 with you. And then we'll call it a day.
Who's number 14?
No. All the ones on this page. Oh, sure.
Right on the left.
Sorry.
no, I'm sorry.
That's what I should have asked. How many of you guys are going leaf raking today?
Me.
Awesome. Great days. At least it's not so windy. Thank you for doing that.
Do you want your answer?
Are you ready?
Yeah.
Okay. Start number 14. Start making your little list of your knowns and unknowns. I call that my data table. So I'm ready to have percent yield, actual, theoretical. 14 says if the theoretical yield of an experiment is 10.00 grams, so that one was easy for me because it literally said theoretical yield. How many grams of the product would be produced if the reaction had a percent yield of 78.6%? So I'm going to put that value in percent yield because it tells me in my problem that's the percent yield. So question mark then is the one you don't know. So that means you're going to have to choose from those three formulas that you have now on your green sheet. Which one should you use?
Actual.
Correct. And so it should be actual equals percent yield, right?
Times.
Yep. Times the theoretical divided by 100. All right, so somebody do that math for me.
7.06.
I think it's 7.86. What's your unit here, though? It's grams. Do you have the right number of significant figures?
Yes.
You do, because you had 4 and 3. 3 is smaller. 3, that's your answer. How are we doing?
Not bad.
Good.
These are all the same as this. So you've got 8 minutes. You could pound out the rest of the numbers on this page. Or you can have time as your own, whatever you want to do. Just please don't forget that you need to have your lab written up for class on Tuesday before class begins. And it is a pants lab. So if you do not come in pants, what will happen? You will not be allowed to use the hydrochloric acid as part of your experiment, and I'll take points off because you're not wearing proper protective equipment. Now, it is fine with me if you want to wear shorts that day and have sweatpants that you wear in this room only, for lab only. I'm happy to do that. But I better not see you walking around wearing them other places than here because they'll yell at you. Okay? So pants on Tuesday.